All right, the next question I want to look at is question number 11. Get some things out of there. Let's see. And in question number 11, this is going to come from lesson 47, graphing exponential functions. The biggest part of this is going to come from your graphing calculator. I'll show you how to do that and what I would expect for your work. It's pretty simple on this. What you're going to want to do, let's clear out some of this information, is plug this into our graphing calculator, just like it looks, to the x. And our graph is going to be an exponential decay function. And so I'm going to draw just a real simple graph that's going to look like this. Then I'm going to hit second graph, and I'm going to do a table of values, probably from, I would say -1 down to 3. So I would graph those 4 points, those 4 or 5 points. And that's all I would want for question number 11. Coming down to question number 12. Question number 12 comes from lesson 48, understanding complex fractions. We're going to handle the numerator first. We're going to rewrite the numerator with -2 over the denominator of 1. So we've got 2/3 minus 2 over 1. We need a common denominator before we can add or subtract fractions. So we're going to get a common denominator of 3. Okay, so we're going to multiply our right-hand side by 3 over 3. That's going to leave me with 2 minus 6 all over 3. 2 minus 6 is -4. So we have -4/3 for our numerator. Okay. Okay, and let's come down and do our denominator. We've got 1 over 2 plus 2/5. All right, so we need a common denominator here. And I would say our common denominator is going to be 10. So I'm going to multiply by 5 over 5 on this side and 2 over 2 on this side. That's going to give me 5 plus 4 all over 10. 5 times 1 is 5. 2 times 2 is 4. Let's see. Let's move that over here. That's going to give me 9/10 for my denominator fraction. So what I have is I've got a fraction divided by a fraction. I can't divide fractions by fractions, but I can multiply by reciprocals. So I'm going to take -4 times 10, which is -40. And I'm going to take 9 times 3, which is 27. And that's our final answer. That actually doesn't reduce any further than that. So this is our answer right here. Okay. Let's erase that one. Let's come back up. Question number 13. Question number 13 says, what is the probability of tossing a coin 5 times and getting exactly 2 tails? On question number 13, we want to go ahead and we want to look at lesson 49 using the binomial theorem. And so I'm actually going to turn over there because there's a specific formula that you want to use for this. Lesson 49, in your book, you have a question type that goes with this. Sure, I've got the right book. All right, and so you're going to see this on page 350. They're going to give you some examples of this. And the formula that they're going to show you is going to look like this. I know it's going to be somewhat complex, but it's where we got M combination N P times N, and then Q M minus N. And what's really going to be important here is what M and N stand for. So P is the probability of success, and Q is the probability of failure. But because we're flipping coins here, there's an equal probability of success as failure. So P, let's use a different color. P is going to be 1/2. Q is going to be 1/2 or 50-50 for those. Okay, then we want to look at what M and N are. Let's see. Then the probability of exactly N successes. Okay, so N is how many successes we want. Okay, and M is the number of attempts or trials. Okay, so let's use that information and what we see there. What is the probability of tossing a coin 5 times? Well, 5 is the number of trials. So we're going to have 5 for M there. We're going to use our combination. N is the number of successes. We need exactly 2 successes. So that's going to be that there. We're going to multiply that. We got 1/2. N is the number of successes that I want. So that's 2. Q is that 1/2 again, and it is M. So 5 minus 2. So that's the number of failures that I need to have. So that's why I get 5 minus 2, so I get 3. I'm going to pull up my graphing calculator here to do this for me. Okay, so in your work for this, that last blue formula that I gave you there. So we're going to do 5 math probability. We're going to go down to NCR. That's going to give me my C. 2. Then I'm going to do 1/2 to the second times 1/2 to the third. We're going to hit math. We're going to get our fraction, and our fraction is 5/16. 5/16. Okay. So this formula right here is what we need to see on a question like that. I'm going to understand that you're going to plug that in your calculator to get 5/16, but if you can show me that formula and then the correct reduced fraction, you should have everything that you need. Okay? All right. Number 14, inverse of a function. Question number 14 comes from lesson 50. Finding inverses of relations and functions. We have 2 rules when finding an inverse. The first thing that we want to do is switch the x and the y. The second rule is we want to solve for y. So as I rewrite this over here, I'm going to get x equals 4y minus 1. Now we're going to solve for y. We're going to move everything away from y, so we're going to do the opposite of the order of operations. So I'm going to add 1 to each side, so I get x plus 1 equals 4y. We're going to divide by 4 on both sides. So I'm going to get y equals x plus 1 over 4, or y equals 1/4 x plus 1/4. Either one of those answers would be acceptable on the test. Okay, so those 2 rules are going to be really important, and you do need to show your work for all of that. Number 15. Number 15 comes from lesson 51, using synthetic division. You don't actually use synthetic division here. This is really just a matter of plugging in 2 for your x, but this is the work that I'd want to show. I'm going to use parentheses everywhere where I see x, and put that 2 on the inside. Now, you're probably going to use your calculator for this, but we can do this relatively quickly. 2 to the third is 8. Okay, 2 squared is 4. Okay, 2 times 2 is 4. Times negative 2 is going to be negative 8. 3 times 2 is 6. Okay, so my 8s are going to cancel out, and I should get 6 minus 8, which is negative 2. Question number 15. So we get P. When P equals 2, my answer is negative 2. All right. Let's come on down to question number 16. All right, we've seen this question in our work before. This is really just a matter of where we're going to plug in the 25 degrees that they give me. So without overcomplicating this, we're going to get C to the F to the T equals, we're going to get that 5/9, and we're going to get T, let's see, plus 25 minus 32. And then we're going to solve that portion right there and rewrite it. So that's actually going to end up being -7. Okay, and that's going to be your final answer there. Okay, that's 16. You want to see an example of that? You can go back and watch the video. No, it's over lesson 53. I believe that there's notes for that. Okay, 17. 17 comes from lesson 55, finding probability. A big thing that you need to remember is that probability is number desired over total, number total. All right, Nita cannot remember the correct number or correct order of the 5 digits in her ID number. She does remember that the ID number contains the digits 58371. What's the probability that the first 4 digits of Nita's ID number will be odd numbers? That the first 4 digits. All right, so we know that there is a total of 5 digits. Okay, but how many of them are odd? Okay, well, odd numbers. So we got 5, 3, 7, 1. Okay, so you know the probability on that first one is actually 4/5. Okay, and then on the second one, it's just 3/4 because now we've already used one. Okay, and then 2/3. Okay, and then 1/2. So we would multiply those things. Okay, 4/5 times 3/4 times 2/3 times 1/2. I'm not going to pull up the graphing calculator for you to see, but I will calculate it here real quick. 4/5 times 3/4 times 2/3 times 1/2. And I actually get 1/5 for that, and that is our answer. This comes out to 1/5 whenever we calculate that. Okay, so we actually have to find the probability for each of those individual digits and multiply those probabilities. In your calculator, that's going to look like 0.2, but you're going to tell me what the fraction is. Okay, and that's the work that you want to show. All right, number 18. The number 18 comes from lesson 54, using linear programming. There is a video for this, and so I'm going to refer you to that just because it takes quite a long time to solve this question. In fact, for any of the linear programming questions in this review, I'm going to refer you back to your lesson 54 using linear programming video so that you can see those things there. And that'll be a better use of your time. Okay, let's go on to number 19. Number 19, lesson 35, solving quadratic equations, finding the roots. What you need to notice here is that that isn't in its proper position, so we actually need to move either the 2x squared over to the left-hand side or move everything else to the right-hand side. I prefer having that first coefficient positive, so I would move everything else over here. In order to do that, we need to subtract them over to the other side. So we're going to end up with 2x squared minus 12x. And notice because that is a negative 18, we're going to add it to the other side. So we're going to get plus 18 equals 0. Now I'm going to factor a 2 out of it because I can take a 2 out of everything. So that's going to be 2 times x squared minus 6x. Let's see, plus 9. This right here is what I want to reduce or factor. I'm going to get something like this. Notice I've got x squared, so I should get x and x. It's minus plus. The only way to get that is to have a minus minus. And so I'm going to wind up with x minus 3. X minus 3 is negative 3 times negative 3 is positive 9. Negative 3 plus negative 3 is negative 6. Let's see, so this is on 19, less than 35. So we're going to take, notice that each of these are actually the same thing, and if we're solving for the roots, I'm going to take that x minus 3, set it equal to 0, add 3 to the other side, and see that x equals 3. And because this one is the same thing, I don't need to solve it again. X equals 3. And that's all we've got there. Okay? All right, number 20. Number 20 has here using polynomial long division. We'll go ahead and see an example of this. Okay, let's put this down here. So we've got 3 x squared. Okay, so we need to actually look at this a little bit more closely because notice it goes x squared, nothing, x cubed. So we need to start with negative 7x cubed. We need to go 3x squared. And notice that there's no just x in here. So we need to add 0x or subtract 0x, is really not going to matter, and then add 5. Okay, I need all of those terms, okay, to completion. And I'm going to divide by, and we could use long division. It does say solve using long division, so we'll do it. But then I'm going to show you how to use synthetic division on this question, which is going to be a little bit quicker. X is going to go into negative 7x cubed, negative 7x squared times, which is going to give me that negative 7x cubed. And I'm going to take that negative 7x squared times positive 1. I'm going to bring it down here so I get that negative 7x squared. Then we're going to subtract. These will cancel. I'm going to get 3x squared minus negative 7x squared, which is actually going to end up adding them because I have a double negative. So that's going to be 10x squared. And then we're going to look back at x over here. How many times or what will it take to get x into 10x squared? Well, I'd have to multiply it by 10 because the coefficient to x is 1. And I'd also have to multiply it by x to get the x squared. We're going to bring down our 0x. All right, so 10x times x is 10x squared. 10x times 1 is 10x. And we want to subtract. Well, that's going to cancel those out. And 0 minus 10x is negative 10x. Okay, so, and then we'll bring down our positive 5. To get x into negative 10x, we'd multiply it by just negative 10. That's going to give me negative 10x. And negative 10 times positive 1 is negative 10. My negative 10x's cancel out. Okay, don't forget to put our subtraction out front. 5 minus negative 10 is going to be the same as 5 plus 10. So I should get a remainder of 15. So we're going to put that positive 15 over our divisor, which is x plus 1. We're going to check our answer. Negative 7x squared plus 10x minus 10 plus 15 over x plus 1. Now, on this particular question, because I'm just dividing by x plus 1, I can solve for x and divide by that using synthetic division. So I want to show you how to do that again real quick, because on the test, it's going to be quicker. And you're still going to get the same answer. But I do need to do the same thing that I did, which is I need to have that negative 7 first, then the positive 3, then the 0, then the 5. And instead of dividing by x plus 1, I'm solving for the solution of x plus 1, which is negative 1. X equals negative 1. So I'm going to bring down my first term. Okay, then I'm going to multiply negative 1 times negative 7, which is 7. And I'm going to add inside here. So that's going to be 10. Then I multiply by negative 1, which is negative 10. I'm going to add, which is negative 10. Okay, then multiply, which is 10. And then add, which is 15. So it's pretty easy to get that. And then I'm going to look, okay, what was my highest exponent to begin with? I'm always going to be 1 exponent less, so that's going to be negative 7x squared. And I'm going to follow that on down. So this will just be x minus 10 plus 15 because this is a remainder. And I'm going to put that over the divisor, which is x plus 1, not just -1. Okay, so I end up with the same answer, but with really a lot less thinking, a lot less work, a lot less chance of making a mistake. So I will, on any possible question where it says use long division, if it's possible to use synthetic division, I will allow you to. Okay, but you do have to show your work. Okay. All right, let's come up to 21. 21 appears to be, let me double check here. This is graphing linear equations in 2 variables. Okay, a music store is selling posters and CDs. Each poster gives a profit of $3 and each CD gives a profit of $5. The store needs to make an average profit of at least $200 per hour to stay in business. Let X represent the number of posters sold and Y represent the number of CDs sold. Let's see. Okay. Write and graph an inequality showing how many of each item, posters and CDs, the store needs to sell per hour to make sufficient profit. So I'm going to come over here to our graph, if I can find him. Okay. Okay, so we're going to need to make a table for this. Okay. I'm going to come back to the question on 21. All right, each poster gives a profit of $3. So we would end up with 3p. Okay, each CD has a profit of $5. So poster plus CD, we won't use the D there. Okay, the store needs to make an average profit of at least $200 per hour. Okay, to stay in business, let X represent the number of posters, so we can substitute X for P. Okay, and we are going to use Y for our CDs, so 5Y. Okay, and we want an inequality. So this is going to be, hopefully, it's got to make at least $200, so it's going to be greater than or equal to $200. Okay, so because we want an inequality here, or really a graph, we need to solve this for Y so that I can get a y-intercept out of it. All right, so we're going to subtract 3x, so we're going to get 5y is greater than or equal to negative 3x plus 200. Okay, divide by 5. So we get y is greater than or equal to negative 3/5 x, and 200 divided by 5, okay, is 40. So we get a graph that looks, or at least a line that looks somewhat like this. If, let's see, let's pick some things here. Let's go by 5. So let's say 5, 10, 15, 20, 25, 30, 35, 40. So we'd make a dot. Let's make it red. Okay, that's my y-intercept. I'm going down 3/5. If I want to make this a little bit simpler for myself, I can use x and y intercepts. Okay, obviously where x equals 0, y would be 40. We can come up, we can see that if we plug in 0 here. All right, if we're just looking up here, if I plug in 0 for y, okay, I'm taking 200 divided by 3 in order to get my x-intercept. Okay, which comes out to like 66 and 2/3. Okay, so if I follow through, this is going to be a little bit tougher, but 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. So I'm going to be really close to that spot right there. Okay, and so this, because it's an equal to, is going to be a solid line. It's going to look like that. And the next thing that we want to know is what side we're going to shade on. Okay, do we want to include the 0, 0? or is it not? So let's see if 0 actually works. That would mean that 0 is greater than or equal to 40. And because it's not, okay, and I'm using this formula right here. If I plug in 0 for y and 0 for x, is 0 greater than or equal to 40? It's not, so I'm going to end up shading this side of that line. So that would be the correct graph. Okay? All right, so not as hard as it looks. My first thought was, okay, this is a linear programming question. It's actually not, okay? They're just wanting you to create an equation out of it. All right, question number 22. This is lesson 40, simplifying radical expressions. It's not as hard as some of the other ones that we've seen earlier on in our review. There's no multiplying by the conjugate here. It's just simply multiplying by the denominator on the top and the bottom. Okay? On the bottom, this is easy because radical 5 times radical 5 is radical 25. Radical 25 is 5. On the top, I'm going to take 14 times 5, okay, to get that radical. And it's radical 70, but we want to see if we can reduce that. So we're going to use that cake method that I've showed you before. So we're going to find the primes of this. That would be 2 and 35. That would be 7 and 5, and because all of these are prime numbers, there's no duplicates, my answer is really simply radical 70 over 5, but I want to check it before I give that as my final answer. Okay, so that's what we're looking for right there. This is the work we need to show. Okay, and this you're very likely needing to show just to show that it cannot reduce any further. Okay, for your own benefit of knowing that you got the right answer, it's a good way to check. Okay, number 23. Okay, find C, D, and E, F. Give the answers in simplified radical form. You have two methods for doing this. What they're asking for is the distances. And so one method is obviously get the coordinates. Here I've got 0, 4. Okay, I've got 3, 2. Okay, over here I have -2, 1. And down here I have -4, -2. And if you ask, why are we finding the coordinates? It's so that you can use the distance formula. And so I'm going to write the distance formula out real quick. It's x1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared, square root of all of that. And so keep in mind that this is your x, this is your y. If I've got more, if I'm finding between two coordinates, let's call this x sub 1, y sub 1, x sub 2, y sub 2. It doesn't really matter which one you pick as x sub 1 and y sub 1, so long as the other is x sub 2, y sub 2. But you would plug those numbers in. I'm going to use actually the Pythagorean theorem for this. Okay, but in your test, because you can't actually write on the test because it's on your computer, it may be a little harder to do. But I'm just going to count. All right, this is 3, 2. So I got 3, 2. All right, and so what I've got here is a right triangle, so I can use the Pythagorean theorem. So 3 squared plus 2 squared equals my hypotenuse, which is my red line, equals c squared. So this is 9 plus 4 equals c squared. 9 plus 4 is 13. Okay, square root both, and this is going to do all the exact same work. So c equals radical 13, and so that's, EF is radical 13. I can do the same thing over here. That's going 3, 2. And because that's the exact same dimensions as the other one that I worked with, okay, I don't need to do that work a second time. I just need to pretty much say that that I'm working with the same dimensions, and that I should get radical 13 for both. Okay, radical 13 for both on 23. Okay. Okay, now 24 is coming back to the multiplying by the conjugate. Okay, let's look at our lesson number here. Lesson 44, rationalizing denominators. If you notice, there's a lot of these on here, which means you're probably going to get some. Okay, multiplying by the conjugate means multiply by radical x minus radical 5. And we're going to do that on top and bottom. Okay, and then we're going to distribute. We can distribute across the top. So radical x times radical x would be radical x squared. Anytime I multiply a radical by an identical radical, I'm going to get just that whole number. Okay, so in this case x. And then I'm going to get radical x times negative radical 5 is going to be negative radical 5x with all of it in there because that won't reduce on its own. Then I'm going to multiply by some difference. So I'm going to get radical x times radical x again is x. Radical 5 times negative radical 5 is negative 5. If we look at the answer there, that's it. That won't simplify any further. So that's my answer. Okay, that's my answer to number 24. Okay, again, that's lesson 44, rationalizing denominators. All right, on question number 25, 25 comes from lesson 45, finding the line of best fit. You could certainly plug this data into your graphing calculator and find the line, but really what we're looking at here is an approximation of where this next position is going to come in. So you can see that it looks relatively like a line, so it's going to follow the pattern of a line. It's not really scattered. It does have, if we were looking at a correlation coefficient, we would look at a correlation coefficient closer to negative 0.9 because it's close to 1. Or at least close to negative 1. It has a negative slope to it. So let's read the question. A lawn specialist measured the average temperature during different growing periods. I'll get this guy out of the way. And the amount that the grass grew during each period. The scatter plot shows the results of his study. Based upon this plot, predict the growth that would occur if the temperature were 85 degrees. So at 85 degrees, we're situated about here. And so we're looking at a position that's somewhere between here and here. All right, that's easy enough to kind of approximate that between those two is this position. So we're going to follow, we're going to say that our growth is approximately would approximately be 4 centimeters. Okay, 4 centimeters is what we would write in there. It would be awfully close to that. Okay, number 26. Number 26, we're going to come back to a lesson 46, finding trigonomic functions and their reciprocals. If we're doing that, remember we're going to be using sine, cosine, or tangent for this. So we want to set up our equation likewise. We want to be able to identify opposite, adjacent, and hypotenuse in terms of what we have and what we need to find. So we're going based upon our 10-degree angle. 10,000 feet is opposite to that angle. D, which is what we're solving for, is adjacent to that angle. So what uses opposite and adjacent? Tangent does. So tangent, and then we're going to put in our degree, which is 10 degrees. Okay, then our ratio, our trigonomic ratio, which is opposite over adjacent, so 10,000 over D. Now this one does require an extra step because the variable that I'm looking for is in the denominator position. So I'm going to multiply by D over D. That's going to cancel these D's out on this side. So I'm going to get D tangent 10 equals 10,000. But because I want to solve for D, I'm going to move this across to the other side. So I'm going to divide by it on both sides. Tangent 10. All right, and then I'm going to take that graphing calculator of mine. Okay, but the work that I need to see is right there, 10,000 divided by tangent 10. But I want to see the process before that. I want to see that you know that tangent 10 degrees equals 10,000 over D. So whenever I pull this up, okay, all I need to do is 10,000 divided by tangent 10. Okay, and what I really should have done is check beforehand, check our mode. Okay, my mode is in degrees. All right, so I'm getting 56,712. I want to check my answer key because that seems almost like an unreasonable answer, but it's not. The answer here, because they want it to the nearest foot, that 0.8 is going to round up. So I'm actually going to get 56,713 feet, okay, is my distance. Okay, that's 26. Let's look for question number 27. Okay, 27 is a linear programming question, but it's not as hard as many of the others because all the work is really done for us. Which point gives the minimum value for p equals 3x minus 2y in the feasible region? The feasible region is the shaded region, but the points that we're going to check are going to be the vertices. Okay, so we're going to want first to find the coordinates of these. So starting with here, we got u is 0, 1, r, okay, is 1, 4, s is 4, 1, and t is 2, 0. And in this case, we're looking for the smallest number I can get. All right, so let's see if I can do this. So we're going to do, let's start with u and work our way around. So it would be 3 times 0 minus 2 times 1. Okay, well 3 times 0 is 0. Negative 2 times 1 is negative 2. Okay, remember, we're looking for the smallest. So then we're going to get 3 times 1. We go around minus 2 times 4. So that's 3 minus 8. 3 minus 8 is going to be negative 5. Keep going around. We got 3 times 4 minus 2 times 1. Okay, so we've got 12 minus 2, which is 10. And then finally, we've got 3 times 2 minus 2 times 0. Okay, so we've got 6 there. So 1, 4, which point gives the minimum? We're looking for the 1, 4, so we would say R. R gives me the minimum, gives me the smallest number there on 27 with coordinates 1, 4. R, 1, 4 is my minimum. Okay, it's a relatively easy question if we know what we're doing with it. 28. 28 is another linear programming question. This is not a question that we've worked out, but you're not going to see this question on the test. And it would take quite a while to work out, more so with 28 and 29. Both of those are linear programming. We have actually done 29 in class. Question number 29, again, I would say go back and watch that lesson because you're going to get a lot more out of it by going back and watching it specifically. And that's coming out of lesson 54 using linear programming. So go back. I don't necessarily know how to link this or anything like that. If I can figure it out, I'll go ahead and link it in so that you can see it or find it and go back to that lesson and watch that video. But like I said, you're not likely to get a linear programming question with that level of difficulty on the test. Okay, so let's get into our last question here, number 30. The probability of drawing a green marble from a marble bag is 90%. What are the odds in favor of drawing a green marble? So this comes down to understanding the difference between probability, which is number desired, over number total. Okay, this is probability. And understanding odds. Odds. Okay, so I don't get these lines confused. Odds are number desired over number of undesired or unfavorable. Okay, so we're going to take our probability, and they tell me that the probability was 90%. So let's convert 90% into a decimal. 90% equals 0.9. Now we're going to take that decimal and we're going to convert it into a fraction. This is 9/10. So let's write it as 9/10. And so that means that in my probability that I have 9 desired over 10 total. Okay? If I want to change that over to odds, and it is odds in favor, so our desired is still 9. Okay? But now we want undesired. Well, this 10 means that there are 10 total. Okay, so if 9 of them are favorable and there's 10 total, that means that there's only one unfavorable option. Okay, so our answer in there is 9 over 1. You could write it as 9 to 1 or 9 to 1. Any one of those 3 options there will work as an answer for that question. On number 30, that comes from lesson 55, finding probability. This should finish out the questions for your review. Look over them, watch them, work them out yourself, follow along. I think the audio on this hopefully turned out quite a bit better than some of the other videos. So anyway, I can give you the whole like, subscribe, notify, comment, do all that kind of whatever, or don't. It's up to you. Okay, all right, that ought to be it, and good luck on your test.